a sleek magnetic projectile traveling flawlessly at extreme speeds, before unseen friction suddenly shatters it into chaotic shards. That is what happens when you introduce massive power without precise, step-level control. In enterprise AI, the main point of failure is no longer acquiring new capabilities. It is utilizing those capabilities safely at scale. While the industry fixates on deployment metrics and the latest models, front-runner organizations are hitting a completely different bottleneck. They struggle to maintain execution speed and output quality simultaneously without losing operational control. This is a diagram of the standard DTRM version 1.0 governance architecture. We have a clean two-tier model, strategic authority at the top, and the agent execution runtime at the bottom. But look at the space between them. This empty space is the accountability vacuum. This vacuum creates structural deficiencies. First, there is no step-level ownership of the human-to-agent handshake. Agents execute rapidly in the runtime tier, while remaining entirely disconnected from the strategic authority above them. Second, there is no mechanism to continuously improve the agent's competence. Configuration happens once at deployment, treating the agent as a static piece of software rather than maintaining a living record of its evolving skills. Finally, while technical rollback exists, it lacks the decision traceability and human authorization required to make recovery a governed institutional act. These three failures are exactly what the version 1.1 utilization governance layer is designed to solve. To safely scale autonomous workflows, organizations must physically build an operational tier that makes governance live inside the workflow fabric itself. We need to insert a new physical layer inside the existing enterprise architecture. This utilization governance layer bridges the strategic and execution tiers. This middle layer is powered by three distinct roles, each embedded directly into the workflow fabric, operating below the head of AI but above the agent runtime. First is the Workflow Step Orchestrator, or WSO. They sit at ANA Layer 4, the Cross-Module Synchronization Protocol. The WSO owns the human-to-agent handshake at every workflow node. They translate strategic principles into actual boundary decisions, determining what executes autonomously and what triggers human review. Next is the Agent Skill Definer, operating across ANA Layers 1 and 2. The ASD acts as the institutional learning and development officer for AI agents. They end the deploy and forget mentality by maintaining a continuous, versioned record of what each agent is certified to do. Finally, the Decision Register Custodian drops into ANA Layer 3, governing self-healing contracts. The DRC is the accountability anchor for the entire model. They authorize any backtracking event, ensuring that recovery is documented and learnable. None of these roles replace the Chief AI Officer or Responsible AI Leader. They exist to operationalize those strategic mandates down in the trenches. By embedding named roles at specific AINA layers, the governance vacuum is eliminated. Every autonomous node now has a specific human owner. Of course, assigning a title isn't enough. These roles require structured, auditable data artifacts to actually enforce their authority. The Agent Skill Definer owns the first major artifact, the Skill State Manifest. The SSM functions as a living certification record, dictating an agent's permitted actions based on current data rather than past deployment assumptions. The governance rule is absolute. No agent receives an autonomy tier upgrade without a certified skill state manifest from the ASD. Meanwhile, the Workflow Step Orchestrator relies on their own artifact, the Decision Register. Standard IT audit logs record what happened. The Decision Register records why. It captures decision intent by recording context snapshots, agent confidence scores, and critical flags marking if a human intervened. Together, the SSM and the Decision Register transform abstract governance policies into rigid, trackable data requirements exactly at the moment of execution. Rapid AI execution can often act like ink bleeding aggressively through a pristine grid, where unchecked speed actively destroys the structural integrity of the work. This poses a difficult operational question. How does the WSO mathematically determine if an agent is performing well enough to act autonomously, or if it must be forced into a human review? This chart shows the solution, the Utilization Quality Index, or UQI. It plots a speed index against a quality index, anchored by a strict enforcement threshold line. Imagine an AI agent operating incredibly fast, but with terrible accuracy. If you use standard arithmetic averaging, high speed offsets low quality. The agent falsely passes the threshold, and its quality failures are masked. Version 1.1 solves this by using a harmonic mean. This calculation mathematically penalizes any extreme imbalance between speed and quality. The system reacts immediately. Dropping below the threshold triggers an enforcement marker. The agent's autonomy is revoked, and human review becomes mandatory. The Utilization Quality Index ensures that raw execution speed is never permitted to blind the enterprise to degrading output quality. Even with precise thresholds, autonomous agents will eventually encounter unmapped exceptions and fail mid-workflow. Standard IT rollback remains non-compliant in version 1.1 because it erases the context and the decision intent of the failure. To fix this, the decision register custodian utilizes their own construct, the resilience tracelog. Every backtrack event requires explicit human authorization from the DRC. The log firmly links the triggering decision to a specific authorized recovery path. But the most critical mandate inside the tracelog is the mandatory learning captured field. The log routes this captured learning data directly back up to the agent skill definer. The ASD uses this data to update the agent's skill state manifest, registering the failure as a new skill gap requiring training and certification. The RTL establishes backtracking as a permanent institutional learning mechanism rather than a technical recovery step. Now, let's look at the complete utilization governance layer in action. The signal originates and is classified. It validates against the ASD's active skill manifest, successfully clears the WSO's harmonic threshold check, executes autonomously, and is permanently recorded in the decision register. Despite adding intense operational rigor, this version 1.1 extension does not rewrite any core pillars of the original DETRM framework. It is fully backward compatible, meaning existing implementations require only additive changes to adopt this standard. Looking ahead, the true future of enterprise AI will absolutely require these massive, complex systems operating in perfect, governed synchronization. Competitive advantage no longer lies in deploying the most capable model. True advantage belongs to the organizations that can govern the operational utilization of those models, maintaining equal speed and quality at all times. The AINA version 1.1 utilization layer provides the definitive architectural blueprint for scaling autonomous AI with total institutional control.